Okay, for the next topic, we are going to talk about the cauchy equation, which has the general form as this. A0 times x to the power n times the n differential of y plus a1 times x to the power of n minus 1 times the n minus 1 order of y, and plus until an minus 1 times x times the first derivative of y plus an y is equal to xx, where a0, a1 until an are constant, and a0 is not equal to 0. So if you take a look at this type of differential equation, you will see that the coefficients of each derivative term of y are the variable coefficients. So you cannot use any previous technique to find the solution of this differential equation. But you can still using the reduction of order. But as I told you before that for the reduction of order, you can use with the second derivative differential equation. If the higher order than second, it would be difficult because you've got to reduce every time until it goes to the first order of differential equation. And another thing is that this type of equation, they have the pattern of that. For example, if you take a look at this term, you have the n order of y is times with x to the power n. So the power of x and the order of differential would be the same. So for the second term, you have the order of n minus 1. So the x is, again, the power of it is n minus 1. If you take a look at this, this is the first derivative of y, so it's times with x to the power 1. This one, you don't have differential of y, you have only y. So actually it's times with x to the power of 0. But x to the power of 0 is equal to 1. So that's why we don't put any x in there, because x to the power 0. Okay. So it's saying that if you have this type of differential equation, the way to find the answer of it is just, you've got to do this way. First, you assume x equal to exponential of t. So what are we going to do is just that we are going to change the independent variable x to t, and then we are going to write down our differential equation in the terms of y and t. To assume x in this way, we can get rid of each x term and change this differential equation into a constant coefficient differential equation. Okay. So from our assumption, we would get t is equal to ln x. This is for the final, that whenever we finish, like I said, we are going to write down the term of dy by dt, like change the variable to t, so at the end you would get the answer in the terms of y and t. And the thing is that you just cannot answer it as a t, because t is just whatever you assume. So you got to change your t back to your x by using this definition. And with this definition, you also know that if you do the differential of t, it will be equal to 1 over x dx. Or we can say that dt by dx is equal to 1 over x. Now, we are going to do this term, dy by dx. We want to make it to be dy by dt. So, we are going to use the chain rule. Anybody know chain rule, right? Chain rule saying that dy by dx is equal to dy by dt times dt by dx, right? Is that what our chain rule, right? You see dt and dt, it is the same, they cancel out, so at the end you would get dx, dy by dx. Now, we know that dt by dx is equal to 1 over x, right? Actually, everything is just come from our assumption. And for our assumption, it's giving us that dt by dx is equal to 1 over x. So, for the product or the time, it has the property of exchange or alternative position, right? So dy by dt times dt by dx is equal to dt by dx times dy by dt, right? It's just the same, right? And we know that dt by dx is equal to 1 over x. So you would get 1 over x times dy by dx. Oh, dy by dt, I'm sorry. So that means our dy by dx is equal to 1 over x dy by dt. So I have x down here, put it up there. I would get x dy by dx is equal to dy by dt. I said that, oh, in that case, you see that this term is equivalent to this term of our differential equation, right? Right? You have x dy by dx. Here, x dy by dx is equal to dy by dt. So, by this assumption, you can change the term which has the variable coefficient to be a constant coefficient. So this one I would write down as a dy. And then now my d is equal to d something by dt. Right? Now our capital D is d by dt. It's not x any longer anymore. Right? It's become d by dt. Now, what if we do the second derivative of it? You would get right, and then we put dy by dx is equal to 1 over x dy by dt, right? We are going to do the second derivative of y. We know that the first derivative of y is equal to 1 over x dy by dt. So, for the second derivative, we just take this term and do derivative by x. Okay, so we would get and then both of them are a function. So when you do derivative of this term, we've got to do the derivative of the product term, right? So we would get 1 over x times d by dx of dy by dt plus dy by dt times d of 1 over x by dx. What is the d1 over x by dx? What is the derivative of 1 over x by dx? What is the first derivative of 1 over x by dx? Minus 1 over x squared, right? So we would get 1 over x squared d squared y by dt squared minus 1 over x squared dy by dt. Then both of the terms have 1 over x squared, so we take 1 over x squared out. So we would get inside is the second derivative of y by dt minus the first derivative of y by dt. You have x squared here, you put it to the term of y squared, the second derivative of y to x, so you would get on the right hand side, you are going to write it down in the form of operator d. So you would get d squared minus d times y, or d times d minus 1y. Now, you see, for the first one, you said that if you have x dy by dx, it's equal to dy. Now you have x squared d squared y by dx squared equal to d times d minus 1y. Saying that if you have x to the power n times the n order of derivative of y by x, it would be equal to d times d minus 1 times d minus 2 times until d minus n plus 1. Here is the things that you are going to test to use. Okay, and now your d is mean d by dt. So, in order to get this definition, the meanings of this formula, it's coming from the assumption that x is equal to exponential of t. Now take a look at the example.